And now, dear grade 11 students, we'll continue the last part of these videos about derivatives of functions and their domain of definitions. And here is example 9. In this example, f of x is equal to 4x cubed minus 9x over 3x minus 1, which is in the form of u over v. Now the denominator is 3x minus 1, so the condition is on the denominator that it should not be 0. Then x should not be 1 over 3. Thus the domain of definition of f is r minus 1 over 3, which is represented as follows in the interval form from minus infinity to 1 over 3 open union from 1 over 3 to plus infinity. And here we start finding the derivative of f of x using the property of u prime v minus v prime u over v squared. Now let u be the numerator, which is 4x cubed minus 9x. Then definitely u prime is 12x minus 12x squared, because we decrease 3 by 1 minus 9. And v is the denominator, which is 3x minus 1. Then v prime is 3. Thus f prime of x is equal, applying u prime v minus v prime u over v squared is equal to that one. When we make some calculations and simplifications, we get 4x cubed minus 12x squared plus 9 over 3x minus 1 squared. And also the domain of definition of f prime is the same as that of f, which is r minus 1 over 3, because we still have the same denominator but raised to the power 2. So similarly, the f prime is equal to r minus 1 over 3 also. Now here comes the example 10. F of x here has the form of x power 7 plus 2x squared multiplied by radical x plus 5. Now there is a condition for the value under the radical. It should be, as we always keep saying, that it should be greater or equal to 0. So here x plus 5 should be greater or equal to 0. Then x should be greater or equal to minus 5. And thus the domain of definition of f is from minus 5 till plus infinity. So it's closed at minus 5 because we can put it greater or equal to 0 because we don't have it in the denominator. Then f of x now has the form of u dot v. So we are going to apply the rule of u prime v plus v prime u for f prime of x, and let's get started. Now let u be equal to x power 7 plus 2x squared. Then u prime is directly 7x to the power 6 plus 4x. Now let v be equal to radical x plus 5. Then v prime is 1 over 2 radical x plus 5. Here there is a note that I have to mention, that if I have a function that's equal to radical x, its derivative is 1 over 2 radical x. Similarly, if I have a function that's of the form radical x plus 5, its derivative is also 1 over 2 radical x plus 5. But if it was of the form, for example, 4x plus 1, then the derivative of this one is gonna be 4 over 2 radical 4x plus 1. Because x here is multiplied by a constant. So as if we are applying the rule of radical u prime is equal to u prime over 2 radical 2. So if x is multiplied by constants, or it's not a simple x inside the radical, then we have to find the derivative of this one and then divide by 2 radical u. Okay, so we consider that u is 4x plus 1. We find its derivative, which is 4, and then we make it 2 radical u. Okay, but here x plus 5 is has the same idea. Radical x plus 5 has the same idea of radical x, so directly we put that v prime is 1 over 2 radical x plus 5. Let's continue to find the derivative. So f prime of x is u prime v plus v prime u, as I mentioned before. Then it's 7x power 6 plus 4x, which is u prime, into v into radical x plus 5 plus 1 over 2 radical x plus 5, which is v prime, into that one, which is u. Notice now that we have a radical in the denominator. Then the condition now for the value under the radical is not greater or equal to 0. It's just strictly greater than 0. It's strictly positive without putting or equal. Thus, x is or should be greater than -5, and that's why the f prime is gonna change into -5 opened till plus infinity. So that's the domain of definition of f prime. It differs from that of f by opening the interval at -5, because here we don't have to put x plus 5 greater or equal to 0, because it is in the denominator. The radical x plus 5 is in the denominator. Okay, now let's visit GeoGebra to have a look at the graphs of these functions, f of x and its derivative, f prime of x. And here we go. If you notice, that's f of x. Its graph is in purple. Look at it at -5. It's defined at -5 here. Notice. While the derivative, that one or that one, if we continue calculations, we are going to get that answer. Okay, but we can keep it like this. We don't have to continue and make calculations. We can keep it like this to save time. If we continue calculations, we are going to get that answer. Notice that the derivative is not, the graph of the derivative is not defined at -5. Okay, it's the brown one. Now let's continue talking about the last example, which is f of x equals radical x squared -9. Here it looks like radical u. So we are going to apply the rule of the derivative of radical u, which is equal to, so radical u prime is equal to u prime over 2 radical u. Let's first of all make the condition for the value under the radical. X squared minus 9 should be greater or equal to 0. Now the roots for that one are -3 and 3. Now how to determine the position where this value or where this value is exactly positive? So we just make the sign table. Okay, here is the sign table. We put the numbers that are roots, -3 in the increasing order, and the 3. Here is for -infinity, here is for +infinity, and here is for x, and here is for x squared -9. Then here are the roots for the value x squared -9, and as you know, same as x squared, opposite between the roots, and same as x squared. So plus, minus, plus. Thus, we need the positive part, we need the positive region. So we have to talk about that region and that region, and that's why df is gonna be equal to the opened interval -infinity -3 closed at -3, and then closed at 3 till +infinity. So here we go with the domain of definition of f. So it is, as I said, from -infinity to -3 closed, union from 3 to +infinity. Now how to find the derivative of f of x? Let u equals the value under the radical, which is x squared -9, then u prime is 2x. So applying the rule I mentioned, f prime of x is equal to u prime over 2 radical u, which is 2x, over 2 radical x squared minus 9. Cancelling 2 by 2, we'll get x over radical x squared minus 9. Now notice that radical x squared minus 9 becomes in the denominator. So the domain of definition of f prime looks like that of f, but we have to append the intervals at the roots of x squared minus 9, and thus df prime is equal to the interval append at minus infinity, of course, till minus 3 append union 3 again append at 3 till plus infinity. And let's finally visit GeoGebra to have a look at the curves of f of x and its derivative. Okay, let's look at the curve of f of x. That's the curve of f of x. Okay, look, it is defined at minus 3 and 3. Okay, and we can find the answer of minus 3. We can find the answer of 3. Okay, it exists. While if you look at the graph of the derivative, here is minus 3 and here is 3. Look at the curve of the derivative. It's not defined at 3 and minus 3. F prime of minus 3 and f of 3 don't exist. Look, f prime of minus 3, it gives infinity, and f prime of 3 will give plus infinity too. And thank you for watching these videos. Hope you enjoyed derivatives and domain of definitions. Meet in other videos, inshallah.